7.1 is exponential growth and decay. Specifically, we're going to be graphing exponential growth and decay problems. So what I want you to know, first of all, is let's just know what they look like ahead of time. Exponential growth is going to look like, here's the axis, and you're going to have something that looks like a ski slope. Okay, going to look something like that. And then exponential decay is going to be pretty similar, except it's going to be decreasing. All right. Now, something to notice is there's something called an asymptote. And an asymptote is just like a flat line that the graph approaches but doesn't really touch. Okay. It's going to get closer and closer and closer to flat. And in a growth problem, the flat part is on the left side, and in a decay problem, the flat part is on the right side. But that's called an asymptote, a horizontal asymptote, and you'll see as we graph those. So mainly, those are your two graphs. Now, you might have to flip them upside down. If you see a negative sign, we might be flipping that picture upside down, but it's either one or the other. All right? Now, how you're going to recognize which one's which is when it says exponential growth. Think about the term exponential. There's going to be an exponent on it. So growth is going to have like a 2 to the x power or a 5 to the x power or something like that. All right, you can have a number raised to an exponent. Decay is kind of the same thing, except you're going to see probably like a fraction. Specifically, you're looking at a number between 0 and 1. All right, it's not necessarily a fraction, because if I had this fraction, 3 over 2 to the x, that would still be growth. So I can't just say it's a fraction. If it's a number bigger than 1, then it's going to grow. If it's a number between 0 and 1, it's going to decay. So if I gave you 2/3 to the x power, that's going to be decay. All right. So look at all of the problems on this page. All of the problems on this page, they're all growth problems. So you're like, well, look at number 2. Number 2 has a fraction on it, 1/3. But that 1/3 doesn't have an exponent on it, right? What number has the exponent on it in problem number 2? 7. Okay, bigger than 1. That's going to grow. And, right here, number 3, number 4, you've got a lot going on. But specifically, I'm looking at that 2. The 2 is the thing that has the exponent on it, right? In both of those cases. Now look at the back. Number 5, number 6, those are going to be decay problems. And what about 7 and 8? 7 is decay. 8 is growth. All right, so we can recognize what the graph looks like before we even start. Now, let's go ahead and start graphing, okay? One thing that's not written on there, but could be, is at the end, if you think about this graph as plus 0, that's where the asymptote is. That 0 is where the asymptote is. And that's kind of an important part of this graph. So I'm going to put a dotted line. I want you to draw this in there. A dotted line at y equals 0. Right there at the bottom. It won't always be at 0, but this one is. And essentially what we want to do is make a table and graph some points. Okay. So you don't have to do a lot. You just have to do enough to where we can draw a good line. All right. What's a good number to plug into a table? Almost always. Okay. 1 is good. 0 is also good. Let's start with that. All right. So if I made a table and I plugged in 0, you would have 2 to the 0 power. 2 to the 0 power is not 0. Anything to the 0 power is 1. Very good. So we would have the point 0, 1. Go ahead and graph it. And then if I plug in 1, I'd have 2 to the first power, which is 2. I've got the point 1, 2. 1, 2 is right there. All right. Now, here's the key to this, to me. If you already know what a growth problem looks like ahead of time before you even start, then I don't think there's much more you need to do. You can make more points if you want, but I'm not going to. What I'm going to do is I know it gets flat on the left side up against this dotted line, and then it's going to curve up like this. All right? So make sure you don't cross over that asymptote. But that's what your graph's going to look like. Okay, so let's look at the next one. The next one's kind of weird because of that fraction, but we can still do the same thing. Notice the plus 0 at the end. That's going to be your asymptote. Go ahead and draw that in. Don't get lazy and skip this part. I want to see that dotted line. So draw it dark enough so where I can see it. And then let's plug in a couple of numbers. Again, 0 and 1 are probably going to be your easiest ones. You can do other numbers. You can do more numbers. But a lot of the times, those are the easiest numbers to make. Okay? So if I plug in 0, I would have 1/3 times 7 to the 0 power. Well, you should know 7 to the 0, anything to the 0 is 1. So that means we have 1/3 times 1, which is 1/3. That's going to be kind of hard to graph, but we can do it. Okay, zoom way in there. You've got to graph the point 0, 1/3. So go, eyeball that up and put it about 1/3 of the way between 0 and 1. Now, if we plug in 1, you'd have 1/3 times 7 to the first power. Okay? You've got 1/3 times 7 is about 2.33. Okay? So use a calculator if you need to. But that's about 2.3. So I've got the point 1, 2.3. Right about there or so-ish. Feel free to do more. If you plugged in 2, you'd have 1/3 times 7 squared. That's going to be 1/3 of 49. But 1/3 times 7 squared is 16.3. Okay, 16.3 or so. So 2, 16.3 is going to be about right there. All right. So, the more points you do, the better. But you just need to know the pattern. It's going to be flat on the left. It's going to curve and get really, really super steep. Don't go backwards on itself. Make sure it doesn't flip over and go backwards. It's going to get closer and closer to vertical. But it's not going to go back negative. All the problems are pretty much some iteration of this. So we look at the next one. Okay. The next one's a little bit different. A little bit. You've still got plus 0 at the end. And so we've still got that asymptote at 0. Okay? But in this case, I don't want to pick 0 and 1 in my table. I mean, it's fine. I can pick 0 and 1, but there's a smarter way to do it. Okay? If I do pick 0, I'll have 5 times 2 to the 0 minus 1 means I'd have 5 times 2 to the negative 1 power. 0 minus 1. 0 minus 1 gives me negative 1. And there's nothing wrong with that. I can do that. 5 times 2 to the negative 1 gives me 2.5. Zero, 2.5. So you got to eyeball that up, 0, 2.5. And then if you plug in 1, 5 times 2 to the 1 minus 1. Plugging in 1, you get 1 minus 1, that's going to be 0. And again, you can use a calculator if you want to, but we know 2 to the 0 is 1. 5 times 1 is 5. So 1, 5 is right there. If you know the shape, if you've memorized the pattern, I think 2 dots is probably enough for you to draw a quick sketch, okay? If you want to go more, if you want to do more points, be my guest. Plug in 2. 5 times 2 to the 2 minus 1 is 1. That's 5 times 2 is 10. 2 comma 10. Again, the more points you do, probably the better. But I don't know how necessary that is. If you know it's going to be flat to the asymptote, and then it's going to grow exponentially. That's an exponential growth problem. Make it flat to the asymptote on the left side, and then make it grow. Okay? Now, earlier when I was talking about choosing which points you wanted to plug in, one thing we've talked about before is making 0. And if you look at like that exponent, x minus 1, I don't know why I can't. There we go. X minus 1. Think about what makes that 0. What makes that 0 is the number 1. So that might be a good number to plug in. All right. Notice how when I plugged in 1, it gave me 5. That was probably the easiest number to pick. So you can pick smart numbers by making that 1. Now look at number 4. Number 4 looks tough. Notice though, you've got this minus 2 at the end. Okay. That minus 2 is going to be your asymptote. So instead of at 0, this time your asymptote is at minus 2. Now I know that's at the bottom of my graph, but don't count on it being the very bottom of the graph every time. Okay. So what? Let's plug some stuff in. Think about it this way. What's going to make your exponent equal 0? In this case, that's 0. So that's probably a good number to plug in. You have 1/2 times 2 to the 0 minus 2. 1/2 times 2 to the 0 minus 2. If you need a calculator for that, make sure you put your 1/2 in parentheses. 1/2 times 2 to the 0 minus 2 is negative 1.5. 0, negative 1.5 is right there. And then let's plug in another number. It doesn't have to be 1. You could plug in 2 if you want. 1/2 times 2 to the 2nd minus 2. And of course, it's good if you can do this by hand, but if you can't do this by hand, do it by calculator. You just want to get it right. 1/2 times 2 squared is 4 minus 2. 1/2 times 4 is 2 minus 2 is 0. 2 comma 0. Right there. And you plug in something else. Plug in whatever you want. Plug in 4. If you wanted to plug in 4, you could. 1/2 times 2 to the 4th minus 2. 2 to the 4th is 16, so we have 1/2 times 16 minus 2. That's 8 minus 2, that's 6. So 4 comma 6. Notice it's still going to be the same pattern, the same shape. Flat on the left side. And then it spikes up. Exponential growth. Now, number 5 is the first one that's decay. So just memorize. This is going to be decay. When you see that fraction 1/3 of the x, this is going to be decay. Otherwise, we're still going to do the same thing. Plus 0 means there's an asymptote at 0. Draw it in. Don't be lazy. I'm going to plug in some numbers. So if I plug in 0, 1/3 to the 0 power equals 1. So I've got the point 0, 1. And then if I plug in positive 1, I'd have 1/3 to the first power. That's 1/3. 1 comma 1/3 is right there. Got to eyeball it up. Okay. Something I think that's interesting is if you picked a negative number in this case, if you picked a negative number like -2, that's actually not a bad way to go. Because if I plugged in -2, I'd have 1/3 to the -2nd power. and a negative exponent flips your number. A negative exponent says take the reciprocal. So really what that says to do is 3 squared. You flip that number. A negative exponent flips the number. So 3 squared is 9. We could graph the point -2, 9. -2, 9. Right there. Whoops, totally missed. Okay. 3 points is definitely good enough to see what happens. It's flat on the right side this time. Okay. Try and draw a smooth curve. Mine doesn't look that great, but try your best. So if I have, next one is definitely going to be another decay problem. I see +0, so that's where my horizontal asymptote is, at 0. If I plug in 0, I'd have 4 times 1/2 to the 0 power. You good enough to do that in your head yet? 1/2 to the 0 is 1. 4 times 1 is 4. We've got 0, 4. If I plug in 1, 4 times 1/2 to the first, that's going to be 4 times 1/2 is 2. We've got the point 1, 2. Do you feel comfortable enough with 2 points to draw this curve? Okay. I'm okay if you can do it well. Just make sure you're flat to the asymptote. It's going to look something like that. Flat to the asymptote, and then going backwards, curve up. Notice again, this is a decay problem. Decay, it's decreasing. It's getting smaller and smaller. Growth was increasing. It's getting bigger and bigger and bigger. Okay? Something that where this occurs in real life is your investment money. Okay? If you started off making an investment every month, every year, every whatever, it's not going to feel like it grows very much until you get to be my age. And that's the time it really takes off, okay? I highly encourage people to think about investing. Okay, so number 7. First thing I would look at is that horizontal asymptote at -1. That's where it's flat. Second thing I would think of is this going to be a growth or a decay problem? This is decay. That 1/2 makes it decay. So I know what it's shaped like, okay? You guys should know it's going to look like that, right? It's going to look like that. But we just make a couple of dots. Okay? Anybody know what a good number to plug in this one would be? 2 would be a very good number. All right? Basically, we picked 2 in order to make that exponent 0. We're just trying to make our calculations easier. It doesn't really matter, especially if you have a calculator. But plugging in 2 will give me 3 times 1/2 to the 0 minus 1. And you might be able to do that in your head if you know what's going on. Because 1/2 to the 0 power equals 1. 3 times 1, you've got 3 minus 1 is 2. So we'd have the point 2, 2. I don't think 1 point is enough, okay? I think we need at least 2, 3 is even better. You know, however many you want. I don't think 1 point is enough. Make sure you do at least 2. Let's say we did plug in 0 this time. Doesn't really matter what you plug in. But that would give me 3 times 1/2 to the -2nd power. 0 minus 2. 0 minus 2 is -2 minus that 1. Okay. We're following order of operations. Order of operations says we need to do our exponent before we do our multiplication. Don't forget about that. Okay. And how you can do this in your head, don't get confused by the negative exponent. Just the negative flips it. Okay. So the negative exponent flips it into a 2. Instead of a 1/2, it's 2. Instead of 1/2 to the -2nd, it's 2 to the +2nd. Flip it and square it. That's 4. We're going to have 3 times 4 minus 1. It flips it and squares it. That's 12 minus 1 is 11. So you've got the point 0, comma 11, which is right there. All right. Do we feel comfortable drawing that? Maybe. Let's make sure it's flat to the asymptote and then curves up and hits those points. That's not very good. Yeah. Try really hard not to cross that asymptote. It should be flat to the asymptote. Okay, last one, number 8. Is it growth or decay? This is definitely a growth problem. Okay, so -1 is a good number to pick because that's going to zero out your exponent. It'll mean less work. Ooh, but that negative in the front does something weird. Okay? That negative in the front does something weird. Oh, I forgot to do the first step. The first step was this asymptote. See that -2 there? -2 is an asymptote, and look where -2 is. It's a pretty big clue of what's going to happen in this picture, or in this, in this graph. That's your asymptote. So we've got to be flat to the asymptote on one side or the other. Now, you said this is growth, so it's going to be flat on the left side. It's going to be flat on the left side, but that negative flips it upside down. Okay, and so actually I know that this is going to look like that one. It's going to look like that. But anyway, if you plug in -1, you'd have -4 times 2 to the 0 minus 2. -1 plus 1 is 0. And again, 2 to the 0 is 1. So that's -4 times 1. That's -4 minus 2 is -6. We have the point -1, -6. Okay. This is a growth problem. It's just flipped upside down because of that negative. I don't know what else you want to try. You want to try 0. If you plugged in 0, you'd have -4 times 2 to the 0 plus 1. That's 2 to the first minus 2. 2 to the first is 2 times the -4 is -8 minus 2 gives me -10. 0 minus 10 is right there. Okay. It's going to be flat to the left because it's growth, but it's got to hit those points. Flat to the asymptote, hit those points. It's weird to call that a growth problem because it's decreasing, but it's growth with a flip. That's still growth. It's just growth with a flip.